oops, sorry, I forgot the interval. We're supposed to do 0 to 2 pi. So x is somewhere between these, because otherwise there's an infinite amount of answers that could potentially work to solve this equation. So let's see, this is negative 1.5. That's not one of our special ratios. That's negative square root of 3 over, that's negative 3 over 2. This would be one of our special triangles. This would be one of our special triangles, but this one isn't. So I think we have to use a calculator for this problem. So to do that, if your calculator has the function, you could do this. Inverse cotangent to both sides. Right? An inverse operation cancels out this. I did inverse cotangent here. It cancels out. Inverse cotangent over here. And if your calculator doesn't have that, here's another way of doing this problem. Cotangent of x, that's the reciprocal of tangent x. So it means we can write it like this, right? So if we're trying to get x by itself, we've got to get it out of the denominator. So let's multiply both sides by tangent x. And then we'll divide negative 1.5 from both sides. So 1 divided by 1.5, that's, oh yeah, 2/3. That's 3/2, so you're multiplying 2/3 of both sides. So negative 2/3, or you could say negative 6.6 repeating if you want. And then it's the same thing. You need an inverse trig function to get your x by itself. So we want to use inverse tan, or in other words, arctan for some calculators. So that's what we want to solve for. But the problem is there's going to be more than one answer. Okay, your calculator will give you one. So, oh, I should have kept that. 2/3 negative, and I'm going to hit trig, and it's the second button to get to inverse tangent. So it gives me negative 33.69. So x is negative 33.69 degrees. But that's not between 0 and 2 pi. Negative's over here. It's to the left of 0. So that answer's not going to work right now. So we got to draw negative 33.69 to help us out. When you draw an angle, this is where you start from. And a negative degree means you rotate the opposite direction. So this is negative 33.69. So it's got a reference angle right here. Okay? That's where tangent is negative. We got a negative value for tangent, negative 2/3, right? There's another place where tangent's negative. Remember, tangent, any triangle you draw, tangent is the opposite divided by the adjacent. If I draw a triangle up here, the opposite's a positive value because we're going up on the y-axis. And then the horizontal value is negative because we're going left on the x-axis. So it's a positive divided by negative. Tangent is always negative in this quadrant. And if you don't want to keep going through that logic each time, A for all, S for sine, T for tangent, C for cosine. All are positive here. Just sine's positive in this quadrant. Tangent's positive in this quadrant. Just cosine's positive in this quadrant. So the whole point of drawing that is because we got two angles that are going to make this be true. We have this angle that rotates from 0 all the way over here. So let's take the full circle and subtract 33.69 from it. So we get 326.31 is one of our answers. And then the other one, the reference angle is still the same to keep the same ratio, 33.69. We got to find out how many degrees that is. So it's less than a semicircle. 180 subtracted by 33.69. So it's 146.31 for the other angle. Okay, oops. There we go. Those are our two angles that make that equation true.